True. Always true. True. Always true.
Good afternoon. I hope you guys are doing well today. We got something interesting going on. We got functions today. It's going to be exciting. So we have done some functions before, but we haven't done a whole lot of we haven't covered what exactly it is in the course yet. I think we made like one or two of them very, very early on. But we're gonna hopefully cover it a little bit more in depth today. So I hope you guys are looking forward to that. I certainly am. This is let me see. So this will be at so we have our video. We're on chapter 11. Timestamp is 14/12/47. And so this lesson goes for an hour and 45 minutes. Because I'm usually really slow with this, I kind of assume that this will be around 6 hours, so I'm planning to do this in this chapter in two sections. But if we cover the first 3 or 4 really quickly, and then it's like 3 lessons of that just take a long time, then We might end up going longer, but we'll see. We'll see. I usually just do these until I get tired of it. So, anyways, let's get into it. I'm super excited about learning some stuff. All right, there that one pops up. Super professional. Definitely no scuff here. All right, sweet. All right, let's get this show on the road, shall we? Gakwaya Sensei, take it away.
In this lecture, we're going to learn about the one definition rule. And this is a rule that says definitions can't show up more than once in your entire C++ program, or in some cases, a definition can show up more than once in a translation unit. We are going to look at the one definition rule in the context of freestanding variables, functions, classes, member functions, and static members in our classes. In most cases, a definition can't really show up more than once in your entire C++ program, but we have exceptions to this rule. And the exception is for classes. A definition for a class can show up in multiple translation units, and the reason is we need to create objects of those classes, so each translation unit really needs to see the definition for the class. And we are going to try and make this super clear with examples once we hit Visual Studio Code. Okay, so it is time to head over to Visual Studio Code and shed some more light on the one definition rule. Here we are in our working folder. The current project is one definition rule. We're going to grab our template files like we always do. We're going to put them in place, and we're going to open this little guy in Visual Studio Code. Let's do that. We're going to drag and drop. And we're going to have our main CPP file here. We're going to clean it up. That's what we always do. And now we want to explore the one definition rule in the context of variables. So we have a freestanding variable here. And that's going to be the same variable we had in the last lecture. We're going to initialize this. And this is really good. We can use it. We can go in main and use it however we want. We can print the weight. And if we will then run this program, it is going to work. But the one definition rule says we can't have more than one definition for anything. And for this variable here, we have seen that this is both a declaration and a definition. So we can't have more than one definition for the weight name here. For example, if we try and grab it and copy and paste it here, so we're going to try and build this program. We're going to use GCC. We're going to see that we have a problem, and the problem is going to say redefinition of double weight. And it is not going to help even if you take this and put that in another file. So let's create another file to really show you this. We're going to call it some other file.cpp, and we're going to grab our redefinition and move that there. And you're going to see that if we try and build this program, we're going to get the same problem. We're going to have redefinition. So we're going to see, what is the problem here? The compiler error is a little bit different, but it is going to say multiple definitions of weight.
See, that's very interesting because we have not covered using multiple CPP files yet. You're here. Welcome, Lazy. Hope you're doing well. Tara, welcome. P++. I'm curious how this is. So this is the first time we've ever covered having multiple CPP files in one project. So that's interesting. So it's good to know. This is not a concept we've covered yet. Like we've defined things outside of our main before, but I didn't know that it was like, or I didn't realize that it would carry over to other files in the same like folder. Like I kind of figured that if you had, I would have assumed that if you separate these, then it would be different. You include files like libraries. What do you mean? When you say like libraries, is it like you have like a file that has a bunch of different definitions or some shit? Or I guess that'd be more like a dictionary, but like multiple files are part of the same program, same larger program. I'm curious how many files do you use for certain like games and shit. That's kind of interesting. Let's keep going.
and it's going to say 1 is defined in the main CPP file. So this is a linker error. This was caught by the linker because the redefinition is showing up in multiple
Like
files.
you included
So the
IOStream?
linker was linking this program, and it needed to see a definition for wait, and it had seen one definition in the main CPP file, and it has seen another definition in some other file, and this is a problem. The linker doesn't know which one to choose, so it's going to throw an error, and you can't really have multiple definitions for a variable in your C++ program, and this is the one definition rule in the context of freestanding variables like the wait here. But
I'm curious how we deal with this if you have
if we
multiple
go down and
similar
put up our add
things.
function here, we're going to say double A and double B here, and we're going to put the definition below the main CPP file. Let's grab this. We can copy this and put this in the code here. We're going to remove this little thing. We don't want it. We're going to put in our body, and we're going to return A plus B here. Okay, so this is our function. It is working. We can take out what we had here because it has served its purpose. We can say double result, and we're going to add up 10 and 20 like we did in the last lecture. No problem. And we can try and print out our results here. If we build and run this program, it is going to work without a problem because we only have one definition for the add function.
Wait, so when we say single definition, so if like we called this function add. All right, we called this the add function, right? Like add doesn't necessarily the name here doesn't really matter. At least I don't think so, right? Well, let me add double A double B. Let me go back a little bit on this. It matters, that's the name of the function.
Context of freestanding variables like the wait here. But this is the same.
It's what you type in to use
functions.
it.
If we go down and put up our add function here, we're going to say double A and double B here. And we're going to put the definition below the main CPP file. Let's grab this. We can copy this and put this in the code here. We're going to remove this little thing. We don't want it. We're going to put in our body, and we're going to return A plus B here.
So we have that. I don't know why I have this here. That's not part of it. And then we go below our main CPP. So double add double A double B. Then we do this. Return A plus B. Well, it's what you type. So it's what you type in to use it. But like, what I mean, I guess, is that I could rename this to like fucking Chungus or some shit, and then if I call this, it should still be it works exactly the same every time. I could make it something stupid, but like functionally, we want to keep it simple so that we can make sure we know what the hell we're doing with it. Right? Like if I just wanted to add numbers. Okay.
Okay, so this is our function. It is working. We can take out what we had here because it has served its purpose. We can say double result, and we're going to add up 10 and 20 like we did in the last lecture. No problem. And we can try and print out our results here. If we build and run this program, it is going to work without a problem because we only have one definition for the add function. What is the problem here? We have wait defined multiple times. We're going to comment out one definition for wait, and we're going to build again. Now the build is good, and we can run this program. We can kill our terminal here and bring up another one and run Rooster. You're going to see that the result is 30, and the program is working just fine. But if we set up another definition for add, even if we...
I'm kind of curious. Um, didn't we have to define this? Didn't we? I thought I was kind of under the impression we had to define these before our main function. Does it just have to be outside it? What is the? Because this runs, right? Like this just works. You did define it before. So we just have to do this to define that this exists, and then we can tell it what that does later. You defined a virtual function before and then implemented it after. So all I have to do to define a function in the first place is to make sure that it's implemented at some point later. Like I could just name a function whatever and then have that function be whatever afterwards. I was kind of under the impression all that stuff needed to be done beforehand. That's okay. I guess I can kind of wrap my head around that. Like, hey, almost like we have this, and then it's like, hey, heads up, you're going to be needing to look for a function that uses these values.
If we put this in the same file, we're going to get a problem because we are violating the one definition rule. Let's run again. You're going to see the problem here. We're going to see redefinition of the add function. This is not allowed. Your program is not going to compile. We see the compiler error here. Even if you put the definition in another file, that's not going to help. We're going to take this and put this in some other file and trying to compile the program. We're going to get a linker error, and it is going to say multiple definition of the add function, and this is not allowed. This is a linker error, and this time, if we comment out one definition, let's do that. We're going to comment out the one in the main function. This is going to work, and we want to be violating the one definition rule. So this is good. The build is good. We can clear and run Rooster. We're going to see our result here. So the one definition rule says you can't have multiple definitions for freestanding variables or even functions. And we saw that if you do that, you're going to get a compiler error. Let's look at this in the context of classes. We're going to do a class. We're going to say struct, and we're going to call this point like we always do. Mostly, we're going to call this point, and we're going to put in a few member variables. One is going to be mx, the other is going to be my, and this is going to be our definition here. But what you're going to see is that it is possible to have multiple definitions for classes. For example, if we take this and have a copy of this in another file, we're going to do that. We're going to declare this structure here, and we're going to try and build this program. You're going to
What did he call this? MX M underscore. Oh my gosh, I can't type. X and M underscore Y. What are we drawing? Slopes?
see that it is working. We have multiple definitions of these guys. We can go in main, for example, and say point P1, and we can build and see that the program is going to work. Okay, so if you go in here, for example, and try to print std P1 and print X, we're going to do that. We're going to say P1 MX. We're going to be able to use this because this is a struct. The member variables are public by default. We can do this, and we can say P1Y is P1Y MY. Let's do that. And we can say stdndl. What is the problem here? We need to put our output stream operator. I think now the compiler is going to be happy.
So, okay. So we have our point. So struct point, we've defined two terms here, mx and my. So if we do, so we're in our main again. So we do point 1 or point p1, and then we have our std cout p1.x, and we have p1.m underscore x, p1 y, p1.m underscore y, std and align. Oh, whoops. Okay. So then, from what I understand, we're essentially including this in this. 1 a.m. again. It's going to be the same time every day, generally speaking. Either this or later. I don't think I've ever done one of these streams earlier. Sorry, man. P1X, P1. I'll watch on Friday, I guess. I hope to see you there. Let's see. So we're calling this. Why is this called point P1? I don't understand this. Do we name it? I have been watching VODs. I hope you've been enjoying them. It's this is a hell of a journey for me. They're nice. Thank you. Oh boy.
And if we build, we're going to use GCC. We're going to see that if we run the program, we're going to see our things here, and we have some junk values inside because these things are not initialized. But if we initialize them to 0 using braced initialization here.
Wait, is that what I get to? I want to run it. I need to see. I think I do. Yeah, just random values. Yeah, it looks like it. So, but then if we do this, they should both be 0. Rooster. Yep, now they're both 0. How convenient.
We're going to build again.
Okay.
And we should see 0 inside. So let's clear and run rooster. Now we have 0 in x and y for our object here. This is working fine, and we have multiple definitions for our class. But the definitions can't show up in a single translation unit. For example, if we took this definition here and brought that back in main and put that just below our struct here, if we try to build, the compiler is going to complain because now we have multiple definitions for the same class in the same translation unit. For classes...
I notice here that this is not complaining about the doubles, because these doubles are in their own braces. What it's complaining about is point. And you can see here it's a previous definition of struct point, and then the redefinition of struct point. And that's what it's complaining about. It doesn't care about the doubles because they're separated. If we do it, it should show us the same thing. Yeah. Error, redefinition of struct point. Previous definition is on line 8. Interesting. Okay. So we can get rid of it. I wonder what the error code written in crayon. Yeah.
We can have multiple
I don't understand.
definitions, but the
I don't know what a
definitions have to
struct
show
is
up
yet.
in different translation units, and that's what I want you to see here. So we have a redefinition of our point struct, and it is not good. It is going to violate the one definition rule. Okay, now that you have seen this, we also want to see this in the context of a class that also has some static member variables. We're going to take this out because we have already seen this, and we're going to bring in our person class like we used in the last lecture. We're going to add in a new header file. It's going to be called person.h, and we're going to jump into, what did we do? Is this a folder? Let's remove this. We didn't want a folder. We're going to delete this folder. We don't want it. And we're going
Hold on. Did I get rid of it? Okay, I got rid of mine.
to just add a file called person.h. That's our file here, and we're going to put in the content. The content is going to be our person class. Let's close this so that you can see more of this class here.
Oh
Okay,
gosh.
so we have our
Okay.
person class here. We have our include guard. We have our person class definition. We have a constructor, and we have a printf function. We have our member variables, and down below here, you see that we have a static variable, which is person count. We need to
Hold on. I need to see what all this stuff is. So we have our pound if and def person underscore age. And then we have our define person underscore age. And then we have our IO stream, include IO stream, class person. Okay, and then this is something that I don't quite understand what classes are yet. I'm hoping that we'll get some explanation for what all this stuff is. So here we have person, which we're defining as const std string and names param int age param. And then here we go to void print info. I wonder if this is all stuff that I'm like not supposed to be copying in yet. I wonder if I should stop now. Name, full name. Alright, I'll stop after I finish this little block. Age. Because this one has a lot of things that we haven't actually defined in it. So we have like here, and then it's like it goes to private. But like we haven't defined what full name or any of that stuff is. I don't know if any of... Yeah. Identifier age. If NDEF. I don't know. What is the why is this? This looks like it's this, but with two F's for some reason. All right, let's stop getting ahead of ourselves. Let's just watch this because I'm
our person
getting
class
myself
here.
confused.
We have our include guard. We have our person class definition. We have a constructor, and we have a printf function. We have our member variables, and down below here, you see that we have a static variable, which is person count. We need to put in the definition for these guys. So let's go down and do that. We're going to put in the definition for the person constructor. We're going to go on top here and include our person header file. And
Oh, okay, so we can do that. Okay, I need to make another one. This was the... Wanted a new file. And this one was the some other file.cpp. So this one we want to include person age. And I don't know if we need the...
And we're going to put in place our constructor. We can go down and do that. We can say person and say person. That's going to be our constructor. We're going to go back to the class and grab the parameters because I don't want to type all this things. So let's do that. We're going to put them in. We are going to put in our initializer list.
Oh, okay. Okay. I'm not understanding what's going on. We're doing a bunch of stuff, and I haven't been explained as to why or what the fuck any of this is.
We should also delete a parenthesis here. We're going to go down and put in our initializer list. We're going to say full name. We're going to initialize this with name param. And we're going to also put in our age, and we're going to initialize this with age param, the parameter we have from the function. And this is going to be all. Inside the body, we're going to increment the static variable. We're going to say increment person count. We can select that here. And this is going to be good. We also need to initialize our static variable. So we're going to say int person count. Let's do person count. And we're going to initialize this to maybe 8 like we did in the last lecture. And this should be all we need here.
What last lecture?
If we build and run this...
What are you talking about? What last lecture? This is the first time we're doing any of this. Int person count equals 8. And this one we have all of this stuff. Full name, names, param, age param, plus person count. What the hell? We got all this stuff that's in red.
Program, I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to let the compiler figure this out. We're going to see that the build is...
So if you look at our main, it's still just got this stuff. We didn't put everything in the person one. I don't know if maybe that's the reason.
Here
Let's go back a little bit. I want to finish off. I want to put stuff in the...
We have a constructor
in here that we're missing. This is person.h. Okay. So then from here, we have private std string full name int age. And here we go to public static variable declaration. Static int person count. And then down here, it's end if person age. Okay. So we got that. Well, person H is no longer full of problems, which is good. Some other file kind of is. This one still thinks that it's redefining struct point, which it's not. I wish I could like have it recheck that. Can I, if I run this? So I'll clear this. Now it has 9 problems, and they're all in some other file. Okay.
and we have and we're going to put in place that's going to be...
So let's get back to where we were.
Can select that here, and this is going to be good. We also need to initialize our static variable, so we're going to say int person count. let's do person count. And we're going to initialize this to maybe 8 like we did in the last lecture. And this should be all we need here. So if we build and run this
It's
program,
not.
I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to let the compiler figure this out. We're going to see that the build is good.
Why
And
is
we
his
can
build
create
good?
person objects and really use them in our program. So let's come down here and delete whatever we had. We're going to include person. And we're going to go down here and create a person.
What the hell do you mean? I am so confused by what's going on. This is completely fallen apart for me. None of this has been explained. I don't know what's going on. None of this like we just suddenly have like classes and structs, and I can't follow it. We've got 9 issues here. Our code looks exactly the same as far as I can tell, but like I mean, we haven't defined any of this shit. You didn't open the parentheses in the what this thing? Is that literally all that it is? Is that literally gonna fix this? So I do 1 here, and then here? But then we got 1 too many here, apparently. Why is this? Is that literally it? I'm so confused. Expected a primary expression before the colon looks. Check how his looks.
First, whatever create compiler figure. In the last lecture program, I think it's going to run. Let's
God
select.
fucking damn it.
So
Slow down, dude. Slow down. Holy shit. We have person, const, st, string, ampersand, space, names, param, comma, space, int, age underscore param. He doesn't have a thing here. Then it just goes to this, full name, names param, comma, space, age is param, or age param, open, close here. So we have, then there's that. So his looks like this, from what I can tell, unless there's something, like I could just be blind. That is a thing that has fucked me before. Full name should be full underscore name with an underscore. Remove that. You're missing the comma before, the colon before full name? No, I didn't have the space. What the fuck, man? So what is this? Expected a primary expression before. Do I need to do a second one or something? Now it's good.
if we build and run this program, I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to let the compiler figure this out. We're going to see that the build is good. And we can create person objects and really use them.
Well, mine finished with errors. Apparently. Always, let's see. Multiple definitions of add double double. Oh, this thing. I don't know. I don't know if we needed it here, if we wanted it in this one. I don't know if it really mattered. There. This way. God damn it. What the fuck is the goddamn... What is my fucking... Fuck it. I'm getting rid of it. I don't care.
In our program. So let's come down here and delete whatever we had. We're going to include person, and we're going to go down here and create a person object. We're going to say person P1, and we're going to specify the name to be Jon Snow. Why not? And we're going
Alright, so fuck me, dude. It's impossible to follow this. Like I'm... So... You're looking at our some other. So we have our person H. All this shit is finally working.
be all we need here. So if we build and run this program, I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to
Okay, finally.
compiler
Holy
figure
shit.
this out. We're going to see that the build is good, and we can create person objects and really use them in our program. So let's come down here and delete whatever we had. We're going to include person.
Okay, so now we can come here and include person.h. See, I just fucking wish I could understand what the hell we were doing all of this time. We've spent the first, like, half hour of this being fucking lost.
And we're going to go down here and create a person object. We're going to say person P1, and we're going to specify the name to be Jon Snow. Why not? And we're going to say that they are 35. Why not? And we can print information about this person. We can say person printful. And if we try to build this program, let's use GCC to do that. The build is going to be good. As you see down here, we can clear and run rooster. We're going to see Jon Snow. He is 35 years old. So this is working just fine. But we can't have multiple definitions for the same class in the same translation unit here. For example, if we come in the main function, notice we are including person. So this is bringing in the definition for person we have in our person.h here. If we also try to declare another class called person, even if we don't put anything in, the compiler is going to complain because we have two definitions for the same name, which is person here. If we try to build, I think we are going to get a compiler error saying that we have a redefinition. You see, we have a redefinition of person. So this is not allowed. We can't really do this. But notice that this person class is included both in some other file, which is a separate translation unit, and main. We have it included here. So it is really in a separate translation units. We have the definition for the class in separate translation units, and that's not a problem. But if you try and put the same definition multiple times in a single translation unit, you're going to get a problem, and you need to be aware of that. What I want you to see right here is that you can't also have multiple definitions for your static variables and the member functions of your class. For example, if we grab what we have here and also put that in our main function, we can do that. Why not? We're going to come in our main function here and we're going to put the same definitions here. Now we're going to have a problem because the linker is going to see two definitions for the static variable and the constructor for person here. And this is going to be a problem. You can't really do that. If we build, we're going to see a problem. We're going to see that the problem is we have multiple definitions for the constructor and we have multiple definitions for person count, and this is not allowed. You can't really do that. You can either remove the one from some other file .cpp, for example. If we comment this out, let's do that. We can come on top here and comment this out and try to build the program. Now the program is going to work because we have one definition for these guys. You see the build is good. We can even run the program to show you that it works. Or we can remove the one in the main CPP file and we can leave this alive. So let's go back in the CPP file, the main CPP file, I should say, and remove this. And if we build, we're going to see that this is going to work. And we are compliant with what the C++ standard expects us to do in our.
Is this your first look at functions, structs, and classes? Yes. None of this stuff has been explained before. We just kind of created a struct point here and a fucking a class person here. We did technically do a single function way back in the very beginning, but it was like it was very basic, like addition, multiplication, like type functions. It was not a super complicated process. I don't know. I don't really understand what this stuff is, except that like I've created something called person that we can use here, and presumably we're able to take info that we give it, right? So here it's like we take the name that we type in that is a string, and we have the age that we give as an integer, and then it prints the information here, which is this thing. I don't really understand what this private is. I understand that we needed to bring person H in here up like so. Because it needed to be included the same way as like IOStream, or I guess any other of the, like we used C string I think yesterday. It feels like I'm just kind of like, this is the first time in this entire video so far that I've felt like completely like whoa, like explain what the hell's going on and what we're doing, because I don't know. Not really. Like, I don't understand what the point of this is. Like, I don't really know what this struct thing is. The only thing I understood about it is that I can't have more than one. I don't know what this ndif is. This is our some other CPP file, which this looks like it's very similar to something from here. But I guess this one hasn't been incorporated, so it's not causing a problem when we try to build here, because person is still only defined the one time. Here it says we have 8 people. I'm a little bit at a loss. I'm hoping to understand more as we go through.
C++ programs. If we run, we're going to see that this is going to work, and this is really cool. This is really all I wanted you to see in this lecture. The one definition rule, which says that you can't have multiple definitions for the same name in your entire C++ program, but for classes, we can violate this rule a little bit and make the same definition show up in multiple translation units. We are going to stop here in this lecture. In the next one, we're going to learn about linkage. Go ahead and finish up here and meet me there.
Yeah, okay, so that's linked. Amazing. Fucking... Yeah, this just felt very, like... this one was titled... this part of the chapter was titled, the one definition rule. And it seems like he just took a bunch of things that we didn't understand yet, because it seems like maybe we're supposed to wait to actually mess with stuff. You know, first hand on C++ functions, function declaration, and function definitions. Like, it seems to me like maybe this is just supposed to demonstrate that, hey, look, you're not able to do multiple things of the same name, and I don't quite understand why we would go into, because the way that we did this one, the way that this video has been structured thus far, has been like, we'll do our lecture half, and then we go into the second half where we actually do stuff practically and try it out for ourselves to see what it looks like. And I kind of assumed that that's what we were doing here, is like we were supposed to test this out, but what it felt like is that we were just fucking like I didn't understand what any of this meant. All of this felt very like confusing to me. So I don't know. Maybe we're supposed to wait until the next one to actually understand what the hell's going on. I don't know. Uh, 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 I'm gonna open a different file for this problem. We're gonna watch this and then probably get once we get to the actual practical portion of the next section. I'm probably gonna make a different file or use a different file from this because this has a bunch of stuff here that I'm kind of like, what the hell? What the hell is this? You know? I mean, we have 3 different things here. This is the first time we've ever had to make a second file, with the only exception being the very, very beginning when I was making this VS Code thing to set up the environment technically. But that was also like, hey, don't worry about what all this means, just make sure it works.
In this lecture, we're going to learn about functions. A function is a reusable piece of code that you can use multiple times to do different things. It can take input, and once it has input, it can do some processing, and when the processing is done, the function can optionally give you a result. You can think of a function as a machine, which can take input and give you some output. When you give input to the machine is going to do some processing, and then it's going to give you the output, and the output is going to be dependent on the input that you gave to the machine. This is really how a function works in C++. And once you have the machine set up, you can really reuse it however many times you want. Let's look at how a function looks in C++. The syntax is this. You first specify the return type, which may be int, double, or whatever. After that, you're going to specify the function name, and after that, you're going to have a pair of parentheses. Inside these parentheses, you're going to have your parameters, which is going to be a comma-separated list of...
Just from this lesson here, ignore the classes and structs. The lesson is called one definition rule, so all the lesson was telling you is that you can't have variables with the same name. Yeah. I guess.
things you pass to the function, and after all these parameters, you're going to have a pair of curly braces, and inside those curly braces, we're going to have the body of the function. We're going to be doing our processing in the body, and when the processing is done, we can get the result of the function through this return mechanism here. So if we want to get something out of the function, we have to return that thing, and it is going to be visible to whoever used this function. Here is a simple example of a function with no input and output. The syntax is going to be this. Void means that this function is not going to return anything. And you notice that our pair of parentheses is empty because we have no input in this function. We have our curly braces, and inside these curly braces is going to be the body of this function. It's going to do some processing. And when processing is done, we return out of this function. Now remember that I said that this function doesn't return anything because it is of void type here, but we can return, and I'm going to show you the exact syntax of how you can do that. Okay, so we can have many functions in C++, but each function has to be unique, otherwise you're going to have problems in your C++ programs. A function is going to be unique based on its signature. And a signature is really a function name plus the function parameters. If we go back to our example here and try to figure out the signature of this function, it's going to be function name and plus the parameters, and you see that we have no parameters in here. So this signature is going to uniquely identify this function in our C++ program. If we set up another function that has this same function name and doesn't take any parameter, we're going to have problems, even if we happen to have a different return value for the function. And don't worry if this is not making sense yet. We will see a lot of examples, and I am sure by the time we are done with this lecture, you will be a master at using functions. Okay, now that we have seen how we can declare or define a function in C++, let's see how we can use the function. And when you call a function, in most cases, you will want to get something out of that function. So suppose here result var is a variable that is going to catch the result of the function. And we're going to call the function with a syntax like this. We're going to say the function name, we're going to put our pair of parentheses here, and we are going to pass in the arguments or the values of our parameters. This is the syntax. It is going to call the function, and the result of the function is going to be assigned to this result var variable of ours. Here is how you can call a function that doesn't take any parameter. The parameter list is basically going to be empty. And now we're going to look at a few examples of how you can really declare functions in your C++ program. For example, here we have a function called into bar. It doesn't return anything, so we can't catch the result of this function. And it's going to have one input in the form of an integer. So the parameter is called age here, it's an integer. And inside the function, we are going to test if somebody is old enough to enter a bar. So we do a test to see if the age is greater than 18. If it is, we're going to tell them, please proceed. If the age is not greater than 18, we're going to tell them you cannot enter. This is an example of a function you can set up in your C++ programs. Here is another function that is going to compute the maximum between two numbers. It is going to give us a result, so the return value is an integer here. The function name is max, and we're going to put in our list of parameters. And again, these are the parameters. When you are defining your function, this comma-separated list of things we have in this parenthesis are called parameters. And when you call the function, the values that you pass in the places of these parameters are called arguments. So these are a few terms that can really throw you off, and I just want you to be super clear about these things. Once we have the signature of the function set up, we jump in the body and we do whatever we want this function to do. So we're going to say, if A is greater than B, then A must be the maximum. We're going to send that back to whoever called this function, or in other words, we're going to return A. And if A is not greater than B, then B must be the maximum, and we're going to return it. That's what we're saying here. Here is another example of a function that doesn't have any output and doesn't take any input. It doesn't return anything because the return type is void, and it doesn't take any input because the parameter list here is empty. In the body of the function, we're just going to greet somebody and tell them, hello there, and we're going to return out of the function. Notice that for a void function, we can either omit the return statement here, or we can just put it in like this, say return and a semicolon, and whatever C++ compiler you are using is going to accept this as valid C++ syntax. Here is another example of a function that returns something but doesn't take any input.
This does so it kind of makes me wonder why we use int and return 0 here if we can just do void and I don't know, omit this entirely. I'm kind of curious what the reasoning behind it is. I'm sure there's I mean, I've been told that this is just something that we do, but I don't know why, and I'd like to understand it.
An integer, but we don't need to pass something to this function when we call it. It's just going to give us output. We can call it and get our lucky number and use that however we want in our C++ application. I think we have seen a lot of examples of how we can set up functions. Now let's see how we can call these functions. Here is a simple C++ program. In the main function, we just
The return in the main function is the error code of the program. 0 means success, anything else is an error. Because the programs usually have an exit code. 0 means it finished successfully. So it's just like to make it easier to know if it's finishing incorrectly or if it's not finishing at all.
Set up a few variables, a value, b value, a and b here, and we use those variables to call functions. Remember, we set up an enter bar function. The function looked like this, and it was testing to see if somebody's age was greater than 18. If the age is greater than 18, they are going to enter the bar. If the age is not greater than 18, we won't let them in. The function takes input, but it doesn't return anything. So we can call this function like we do here and say into bar. And you notice that we're not catching something out of this function. We're just going to call it, and we're going to give it input, which is 22 here. And the function is going to do its thing. So it's going to let us in because our age is greater than 18. Down here you see we are calling the max function here. We are giving it two inputs, a value and b value, and it's going to return something, and the return value of this function is going to be used to initialize this maximum number variable here. This is what we are doing. If we go down, we see that we can call the maximum function directly and use its return value in an std_cout statement here, and this is going to print out the maximum between a and b. And down here you see we have the function say hello, which is going to just greet somebody and not return anything. Here is another example of how you can call the lucky number. You say lucky number, you pass a pair of parentheses, and this is going to return the lucky number and print it out in this std_cout statement here. Down here we set up a few variables, a and b, and we are going to use them to call the maximum functions. You see we call max a b, or we can even pass in number literals like we are doing down here. One thing I want you to be careful about is implicit conversions that might happen when you are calling your functions. Suppose we have a minimum function like we see here, which is going to be taking in integer parameters. But here we are calling the function with f and g, which happen to be of double type like we see on top here. So
Yeah,
what is
so we
going to
talked
happen
about
is the compiler is
doubles
going
and
to notice that
integers
what we are passing in is not really what the
and
function
how
takes.
that
But the compiler knows that it can insert a transformation from double to integer, and it is going to
doesn't
do
always
that
work
without your
because
involvement.
they
So
have
be
different
really careful about implicit conversions and make sure
different
they are
data
working
types,
to your advantage. Otherwise, you're going to have really
different
hard
amounts of
to
memory they
debug
take.
problems in your C++ programs. One other thing I want you to be aware of is that if we have a function set up like this, this function is going to be taking parameters as copies. So if you have two variables, for example, c and d, and you call this function with those two variables, you're not going to be manipulating those two variables. What you will be working with inside the body of this function are going to be copies of the parameters that you passed in here. So if, for example, you happen to increment either of the parameters, for example, here we increment a and we increment b, the changes we make here inside the body of the function are just going to be affecting copies we have inside the function here. And these copies are going to die the moment we hit the end of this function here. This is something I want you to be aware of, and we will play with it in more detail when we hit Visual Studio Code in a minute. Here is a simple example of how you can call that function. We have two variables, h and I, and we are going to print them out. After that, we're going to call the function. We're going to store the result back in increment result, but the important thing is that we call the function here with h and I. Remember, in the body of the function, we are incrementing h and I as arguments, but the changes we do inside the body of the function are not going to be visible when the function returns. If we print h and I here, we're just going to see the same thing we saw before we call the function. I realize this is a lot of information to take.
Yeah, no kidding.
Now we are going to head over to Visual Studio Code and actually play with this step by step.
Okay, please. Okay, so that was a lot of stuff, and I felt like I was just I was struggling to comprehend all of it. I'm hoping that this helps me understand it a little bit better. It seems, I think I kind of understand some of the concepts, like, oh god, never mind. As soon as I said that, like, any knowledge that I thought that I had just left my ears. So we're gonna just pray that the practical portion is more helpful to me, because I can rewatch the lecture 80 million times, and I probably won't understand it any better than the first time.
Here we are in our working directory. The chapter is on functions. The current lecture is first hand on functions. We are going to grab our template files like we always do. We're going to put this in, and we are going to open this in Visual Studio Code. Let's open the folder, and we are going to go in the correct chapter and choose first hand on functions here. This is what we want to open. And we are going to open our main CPP file and clean it up a little bit. And the first thing we want to do is to set up a function that takes a single parameter and doesn't give back any result. So the function is going to be into bar. We have seen that. The function is not going to return anything, so it's going to be void. Its return type is going to be void. The name of the function is going to be into bar. And what we want to pass in here is a variable to represent the age of somebody. And we know that the age can really not be negative, so it is advised to at least use an unsigned integer type. So we're going to use unsigned int, and the parameter name is going to be called age. Once we have our parameter list, we're going to put in the function body, and remember the function body is going to live within these two curly braces.
Right.
Now this is a valid C++ function. It's not going to return anything. It's going to take a single parameter whose type is unsigned int. Its name is into bar. We can get inside the function and actually do whatever it is we want to do. So once we go in, we're going to test and see if the age is greater than 18, do something. If the age is not greater than 18, we're going to do something else. Let's do that. We're going to say if age is greater than 18, we're going to tell them the age and tell them that they can actually go in. This is logical. And we're going to say else. And in the body of this else block, we're going to say something else. We're going to tell them, sorry, you are too young for this, and we are going to get out of this block here. And this is really our function. Again, let's try to analyze the syntax here. We have the return type. This is required in C++. If you don't put it in, you're going to get a compiler error because you can't have a function without a return type in C++. You notice that we have our squiggly lines here. Visual Studio Code is not happy. So we're going to tell it the return type. We're going to say the function name after that. And after the function name, we're going to pass the parameters. We can have any number of parameters or inputs to the function, but in this case, we just have one because it is enough for our purposes. After that, we have the body, and inside the body, we do whatever it is we want to do in this function here.
I just noticed that he put age greater than 10. That's really funny. If the age is greater than 10, you can enter the bar. Welcome in, 13-year-old.
Because this function returns void, we don't really need to explicitly return from this function here. But this is an exception only for functions that return void. For other return types, you will have to put in the return statement. But even for void functions, you can put the return statement if you want, and you can do that like this. Say return, and you're going to put a semicolon after this. This is also valid C++ syntax.
I'm curious
Okay,
why
now
you
we
would do
have
that if it's
declared the
void.
function.
I'm
It
sure
is
there's a
valid
reason.
C++ function. Let's try and call it. We're going to
Like
go
with
down
this,
in
it makes
main because
sense,
that's
right?
where we want to be calling our functions.
Because you want to return
for
an
now.
you have to return an
And
integer
we are
in
going
main.
to say into bar. We're going to call the function, and you use the function name to call it. And you're going to put in a pair of parentheses and pass an argument to the function. Again, what you pass to the function when you call it is called an argument. But what you pass to the function when you are defining it like we did here, that's a parameter. Okay, so function parameters when declaring functions, and when you are calling the function, what you pass are function arguments. And now we need to pass in some age to this function, and let's say 22. And if we do that, this is going to be a valid C++ program. Notice that we have this squiggly line. It is because we forgot a semicolon here, because C++ requires to have a semicolon after each statement. And now we have a valid C++ program that is declaring a function and calling a function down here in main. We can try to build it. Let's use GCC to do that. The build is going to be good. You see build finished successfully. and we can bring up a terminal and actually try to run this function here. Let's clear and run rooster because our program is going to be called rooster like we have been doing all along, and the output is going to be you are 22, please proceed. Notice that we have this function defined once, but we can call it multiple times. So for example, if we go down here and say enter bar and we give it 15 as the age, and we try and build again. Let's build with GCC. The build is going to be good. We can clear and run rooster. Now it's going to say you are 15. Please proceed. Why is that?
Because you put 10.
Here? If age is greater than 10. We said 10 here. We should say 18. Sorry for this. We're going to build again.
Okay. So
And
this makes more sense.
Accordingly. So let's say rooster here. You are 22, please proceed. You are too young for this, no offense, because the age is 15 here. You can keep calling this function and you're going to see things.
You can call it as many times as you want. This is
I
convenient.
can't really resist, so let's do that. We're going to say for size t, I, and say start from 0, for example, or 1, why not? And we are going to say while I is less than 10 or 20, and we're going to increment I. You already know how to use loops, so we're going to be using this as an example, and we can comment out all these guys in front because we don't want them to print stuff by now. And what we're going to do is call the function with whatever iteration we are at. Notice that we have a size t here, and the function is going to be taking an unsigned integer. So we're going to have implicit conversions from size t to int. Or if
isn't
really
size t
want
and
this to
unsigned
not
int
cause any problems,
functionally the
we can
same?
change the type of our parameter to be size t. This is also valid C++ code. Let's say size t properly. And if we go down here, we're going to say enter bar, and we're going to pass in I. Watch what is going to happen. This is going to loop from 1 all the way to 19, and it's going to be calling this function with whatever iteration we might be at. So it's going to loop from 1 all the way to 18, and it's going to tell us we are too young for this. But for 19, it's going to let us in because we will be old enough to enter a bar. Let's try this. I think it's going to be fun. We're going to build with GCC, and we're going to clear and run rooster. Sorry, you're too young for this. You're too young for this. And once we hit 19, it's going to tell us we are young enough to enter a bar, and we're going to go in and have as much fun as we want.
I feel like this should be greater than or equal to.
Remember, a function is uniquely identified by its signature, and the signature is really the name of the function and the parameters that you have in here. Okay, once you have the function declared, you're going to do whatever you want in the body. You are going to optionally return something from the function, and once the function is declared or set up, you can go in main and call it and do whatever it is you want with it. Okay, now I think we are mature enough to try out a few other functions. Let's go down and put in another function which is going to compute the maximum of 2 numbers. The signature of this function is going to be its name here and the parameters. Notice that we are taking 2 parameters. So this is because we want to be computing the maximum between 2 numbers. And this function is going to return something. We want to get the maximum out of the function and use it to do something else when we call it. So this is the declaration of the function. Once we hit the body of the function, we are going to compute the maximum. We're going to say if A is greater than B, then A must be our maximum. So we're going to return that. And if A is not greater than B, then B must be the maximum. We're going to return B as our maximum here. This is what the function is doing. We can go in main and call it. Let's go down.
So, like, the whole point of this function is just pick the bigger number when we get 2 numbers. That's all it's doing. And we just, like, it just gives us whichever one we passed in there as bigger. Which I kind of... I mean, I guess it has some uses, but, like, it seems very...
Down and comment this out.
It seems like a strange function to create.
So
I'm sure there's...
That's what we were doing. Now we are calling max. So we're going to go down and set up a variable, call it result, why not? And we're going to compute the maximum between 10 and 20. Why not? Okay, so let's see what we get. And we're going to print the maximum this time. We're going to say max is result. Okay, now if we build this program and run it, try to guess what we're going to get. We're going to call the maximum function, and what we pass in here are arguments. Again, we are not passing parameters here. We are going to pass in 10 and 20 as our arguments. And when we call the function, control is going to jump to the body of the function, and we are going to fall inside here. The arguments we're going to pass in are just going to be copied in the function, and we will have them through these names A and B. So we're going to test and see if the first parameter is greater than the second. In this case, the first parameter is not greater than the second because the first one is 10, the second is a 20. Let's go down and see that. And the test here is going to fail, and we're going to run whatever is in the else block here, and we are going to return B as our maximum. When we return B, B is going to basically be the result of this expression here. And that result is going to be assigned to our result variable, and we're going to print it out with this stdc out statement here.
I think it's kind of so that was actually something I remember confusing me when I attempted a college course. Was what the hell an argument was, because it wasn't explained in this way, with the an argument being just what you input in the parameter, essentially, right? Because it's like all we're doing here is, right, we created our function, which takes our parameter is a size t, which is essentially an unsigned integer, that we've called age. And then the argument is exactly the same thing, except that it's when the function is being called, it's the number that you pass through it. So it's nice to get that finally cleared up. But I also haven't fucking thought about this in 10 years? Longer, maybe? Maybe not quite 10. I don't remember exactly. But it was very, it's I'm finding it difficult to talk about this much at all, because it's basically just like, okay, here's the explanation for what we're doing. And it's like we're creating an integer, we're creating a function that returns an integer that what we pass our arguments through, and then it just gives us the largest. I feel, I don't know. It's not.
So let's try and build
I don't know,
this.
man.
We're
I'm
going
like
to build with
brain
GCC.
farting
Again, the
at the
build is
moment.
going to be good. We're going to clear and run rooster. You see that maximum is 20. If we try and change this, for example, make the first parameter 100 and build again, let's see what maximum we get. Going to clear and run rooster. We're going to say that maximum is 100. And again, you can call this function however many times you want. For example, we can call it again and say result equals max using two variables that we have, let's say x and y, and go on top and declare these two variables. Why not? We're going to say int x, and we're going to put in it 22, and we're going to say int y and put in a 44. Why not? And now if we print the result, we're going to get 44 because that's the maximum that was assigned back to our result variable here. Let's build again. We're going to run the task to build with GCC. Can clear and run rooster. You see max is 44. And this is really how you can declare and use a maximum function like this. We're going to comment this out because we have a few more functions we want to try out. Let's go on top and put in another function. And again, notice that we are declaring functions before the main function here. This is a requirement of a C++ compiler because before you use the function must be declared somewhere. So we need to go before the main function and declare our functions here. The function we're going to do now is say hello here. It's not going to take any input and it's not going to give us any output. It's just going to say hello and die off. We can go down and call it. This is going to be super easy. Calling hello. And we're going to call it, say hello. See that even Visual Studio Code knows about this function. We can call it like this. It's going to be activated.
All right, let's create the say hello function. Say hello, boom, and then all it's doing is print out hello there, hello, and then return. This is optional. It's not necessary. And it even says as much. You could omit this return statement for functions returning void. And then we just do the same. All we're doing is calling it. So if we say, if I do that, is that all I need to do?
So we're going to hit the body of the function. We're going to say hello there, and the function
I
is
feel
going
like there's
to
something I'm
return
missing
or
here.
die off. Please note that you could omit this return statement for functions that return void. So if we comment this guy out, the function is going to work equally well. You can use this however you want. Now we're just going to build with GCC and see this function run. The build is good. We're going to run rooster, and it is saying hello there. Let's go down and look at another example here. The next function is going to be...
Okay, hold on. I fucked it up. I didn't see what he...
Say hello. See that even...
Is it just that I need to do the parentheses? Yeah, because now it's actually calling it. Okay. Oh boy. Fuck me, dude. Yeah, there we go. Now it's running properly.
Visual Studio Code knows about this function. We can call it like this. It's going to be activated. So we're going to hit the body of the function. We're going to say hello there. And the function is going to return or die off. Please note that you could omit this return statement for functions that return void. So if we comment this guy out, the function is going to work equally well. You can use this however you want. Now we're just going to build with GCC and see this function run. The build is good. We're going to run rooster, and it is saying hello there. Let's go down and look at another example here. The next function is going to be lucky number. It's not going to take any input, but it is going to give us an output in the form of an integer. So we can call it. Let's go down and comment out saying hello here and say that we want to call lucky number. And we can go down and set up a variable. Let's do that. We're going to say int result. And we are going to brace initialize this guy. So it's going to be initialized to 0. And we're going to say result equals lucky number. And we're going to take the result returned by our lucky number function and assign that to the result variable.
Okay, hold on. Let me... So I have to create the function still. But I feel like he's going really quickly with some of these examples. Like I don't...
And we can...
Like I think he's just copying them in, which, I mean, that makes sense and is fine, but it's like, holy shit, dude. It's like it's very quick.
But it is going to give us an output in the form of an integer, so we can call it. Let's go down and comment out saying hello here and say that we want to call lucky number. And we can
but all lucky number is just giving us 99, right?
Result, and we are going to brace
like it's not actually
guy, so it's going
like
to
it is a function, but
0.
it's...
And we're going to say result equals lucky number. And we're going to take the result returned by our lucky number function and assign that to the result variable. And we can print it out if we want. So we can say stdc out and say result. And we're going to put that out here, say result. And if we build and run this program, we're going to get this guy printed out. We should see a 99 because that's what we are returning from our function here. And result is 99 as you see in the output here. So this is really how you can declare your functions. A function has a unique signature. So for example, intobar here has this particular name. And these parameters here, if you go down, max has its own name and the parameters that it takes in. If you go down, say hello and lucky number are different in their own ways. If you try and set up another function that has the same signature as max here, your compiler is going to freak out. Let's try and do that. We're going to set up another function. It's going to have a void return type. We're going to call it max because we want to match this signature here. And we're going to give it two parameters, int a and int b. And we can do whatever we want in this function. Notice that we have a squiggly line.
Yeah,
If we
because
open
it's
our Programs
violating
tab
the
here, you're going
rule
to see that Visual Studio Code has a few
that we
problems
spent
with
so
this
long
because we are setting up
going
a
on and on
function
about
with
last time.
the same signature twice. Let's try and even make this an int and see what we get. Right now, we don't seem to have a problem, but if we get to run this program, we're going to have problems. Let's go down and actually activate the code to call the max function to really show you this, because you need to know. So we're going to comment out calling lucky number, and we want to call max. We're going to activate the code to call max, and we are going to build this with GCC. Notice what we're going to see. We have problems here. We have a compiler error saying redefinition of int max.
Yeah, so this is going over what we talked about last
one
time.
might think,
Or
what if
last
I name my parameters
last section, the
differently
ODR.
here? For example, I call this guy C and this other guy D. Let's do that.
It
Using
doesn't
different
change
names
anything.
like this is not going to solve your troubles, because if we try and build again, we're going to get the same compiler error. So this is not going to change a thing.
Because it's got
We
the
don't
same
have
name.
enough tools to really understand this problem, but know that you can't have two functions.
Wait, if we don't have
with-
enough tools to understand this problem, why did we go over this problem first before doing this lesson? Like, I feel like this, like we've been told before, we can't define the same, define like an integer that would, like, if we call an integer a, we can't call a second integer a. Like that, this doesn't work because they're two, because it's the same thing. You have to call it something else, like B or C or D or Sue or George or any damn thing. It just can't be the same name. Like why are we? I don't know. I feel like the order of this kind of doesn't make sense to me.
Signature in a single C++ program. And we're going to learn more about this later, but note that the signature of a function must be unique to it throughout your entire C++ program. If you remember this simple rule, you're not going to have many problems. So let's try and build again to make sure we have no more problems in here. The build is good, and we can run the program to see our maximum printed out. So let's do that. Clear, rooster, and max is 44. It is exactly what we expect. The last thing I want to do in this lecture is make it super clear in your mind that what we pass to functions we have been setting up so far are copies. So let's go on top and set up a simple function. The function is going to increment and multiply. It returns a double type. The name of the function is increment and multiply, and it is going to take two parameters in.
Okay, hold on. Let's get this created. So this, I'm gonna just write this in. We're gonna create this function. I think I can minimize all this stuff, right? Yeah. So this one returns a double type. We're calling it increment multiply. It takes two, it has two parameters. In other words, it takes two arguments, is my understanding of how that works, of the double type. Inside, we create our, we have our thing. So first thing that happens when we call this function, we create we print out a line of text that says, or print out something to the terminal that says inside function before increment. And then from here we have our a value that it'll tell us what our A value is, right? The one that we passed through here when we called when we called it. It'll tell us what our first argument is. Essentially, it's restating it for us. And then it does the same thing. Let's do this. It does the same thing for our second argument, and it tells us what they do. And then we create a double called result that we assign the value of incrementing A, and then we multiply that with an increment of B. So what this should do is, like, if we pass in, let's say we just pass in 2 1s. My understanding of this is that it will increment the A and increment the B. So that'll be increment 1, and then it'll be, so it gets incremented by 1, both of them. So then we have 2's, and then we do 2 times 2, and it should spit out 4 as our result. So in order to do that, we have we have this after increment, and then we have our A std end line, and it's the same thing, but for B, so here it tells us what our values A and B are equal. So if, assuming we're still passing through the 1s for both of them, both of these should still be 2. And then our result, return result, our result should be 4. So let's, yeah, we gotta get rid of this still, because we still had 2 maxes. So let's go ahead, let's continue watching the video until he goes to pass this. And I think once we finish this chapter of this section of the chapter, I'm gonna go ahead and call it. I'm a little bit tired, a little bit annoyed. I'm not gonna lie.
A double A and a double B. Once we hit the body of the function, we're going to increment A and B, the arguments that were passed to the function, and we're going to multiply them, and we're going to store the result of that in a result variable. The result variable is what we're going to return to the function, and whoever called this function is going to use that to do whatever they want. What we really want to see is that the changes we do inside the function are not going to be visible to the arguments that we pass to this function here. To really make this super clear, let's go down in main and set up a few variables. We're going to have a double H and a double I. The values are going to be 3 and 4. We're going to print them out, and we're going to call our increment multiply function. Notice that we pass H and I to the function.
Why are we doing outside function before increment and okay, so we have 2 different ones. It looks like we're doing. This one isn't presented as a function. This one is presented as something else. All right, so double H, we're calling this one is 3.00. Then we have another double called I, 4.00. We do I'm just going to go ahead and copy all of this text. I call this one is outside function, and then these are going to be h, fucking hell, and I, and this is h, and I, and this is h, and I. And then, actually, this probably shouldn't have been. This is double increment mult result equals, and we do our increment multiply function where we pass through h and I. Okay, so if we were to just run this as is, I'm going to go ahead and just do, I think we need to just comment all of that out, just for my own sanity. So what we do, we created a double value called h and a double value called I. H has a value of 3.00, I has a value of 4.00. We create a text line that says outside function before increment. And we'll change this to an H, and this to an I, and this to an H, and this to an I. And it tells us what H equals and I equals in each of these. And so it's just printing out 3.00 and 4.00. Then here, we're going to we're creating a new value called increment multiply result, and this is going to go to our increment multiply function. So we have 3.00 and 4.00 passed as arguments. So here, A is equal to 3.00 and B is equal to 4.00. So then our inside function is going to be exactly identical to the last one. So it's going to say 3.00 and 4.00 in these text lines. Then what we're going to do, increment A, so that'll go up to 4, and then this one is going to be incremented, this one is incrementing B, so that one's going to go up to 5. So then we have 4 times 5, so our result here is going to be 20.00. So then our inside function after the increment, it will say 4.00 and 5.00, and then it will return the result, which is 20. So we come out here, and then this result, which remember that this one here, so then this one is 20. So the increment multiply result is now 20. Our outside function, it should still say 3.00 and 4.00 because h and I have not changed in value. All we've done is use the function. Follow that? Let's run it. Clear. Inside function before increment. 3, 4. Inside function before increment. I forgot to change that. Oh, I guess we didn't actually print anything. After increment. Yeah, we never actually printed the results. But after the increment, our inside function is yeah. So outside function before, inside function before, these are identical. Inside function after 4 and 5, outside function after, it's still identical to the beginning because h and I haven't changed. We didn't print out our 20, like we didn't print this result out, which maybe that's another line that's like down here that I haven't seen.
Function, and the result of the function is going to be stored in the enc result variable here. But the return value is really not important. What we want to see is if the changes we do to the arguments are going to be visible on the outside of the function here. So remember, we have h and I here. We pass them to the function. Once we hit the inside of the function, we're going to increment a and b, and we are going to return from the function. So let's see if a, which was a 3, and b, which was a 4, have been incremented to 4 and 5. That's what we want to see. So we're going to build this and run this. So let's use GCC to do that. The build is going to be good. We're going to clear and run Rooster. And notice what we have here. Let's go down and look at the variables again.
It's exactly what we
We
have.
set up h to contain a 3. So before we increment h and I are 4. Okay, so that's what we're going to print here. Once we hit the inside of the function, we are going to say what we have inside the function before we do the operation, before the increment. Again, a and b are 4. So these are copies we have inside. We're going to do the increment, and after we have the increment, a and b are going to be 4. But once we hit the outside of the function and print with this guy here, we're going to see that h and I are
Hello,
still
Walk with
3 and
Technology.
4. So we didn't really affect h and I when we did this increment here. What we affected are copies that were passed to a and b here. And this is something you need to know, because some people will think that because I pass h and I in my argument list here, I can manipulate h and I. What you are manipulating are copies that were made by the compiler to pass the arguments to the function here. This is something you need to keep in mind, and we will learn more about this, but I wanted you to learn this firsthand. And this is really all we set out to do in this lecture. I hope you have a better understanding of what a function is and what you can do with it in C++. We are going to stop here in this lecture. In the next one, we're going to learn a little more about function declarations and function definitions. Go ahead and finish up here and meet me there.
Okay, so I think we're going to go ahead and stop there for today, just mainly because, I don't know, I'm a little bit annoyed with the way that the beginning of the lesson went. So basically just spending all of this, there was a lot of effort spent on talking about like other functions and other files, and how we can't define the same thing multiple times, which would have made sense if it had been presented more. I feel like it could have just been the lecture portion, but like I don't think we actually needed to go in and like explain, like, okay, if you have multiple classes, multiple whatevers, you can't define the same thing even across files, because it doesn't work. The compiler doesn't like that. Which, that makes sense, because we've talked before about how we aren't able to create multiple integers. Like if I create an integer that I call just call it Ragnarok, if I create another one, it doesn't like that because it's redefining the same. It's redefining this. This is already defined. You can't define something with the same name. Even if I call it a double, if I create a function with this name, like not a function. Well, I mean, if I do a function, it doesn't like it because you can't. It's the name is already used. The name is taken. It's like on a website when you're trying to create your username. You can't make multiple things the same name. And we spent a long time doing not a long time, but we spent more time than I felt was necessary, and I was very, very lost and confused. I thought I was supposed to be understanding what the hell was going on, and that wasn't the case. It had me very frustrated, I think is the best way to put it, because I'm totally lost. Like, we're doing things that I don't understand what we're doing. I could kind of put together some of the things, like when we created a class for person, I could kind of put some of that together, but it felt very like patchwork, my understanding. And when we get to the end of it, it's like, oh, we're actually not supposed to understand it at all. We haven't messed with this at all. And it's like, okay, fine, I guess, but that still doesn't feel very good. And then when we did like our functions, I thought this kind of exercise was kind of was more interesting. I kind of I feel like we spent a lot of time on really simple functions when we've done some of these before already. And I think this is a result of this being less one long lesson or one long video, and is my understanding is that this is a collection of the lessons used in like over the course of however long, right? Like this is a very long video, but I think it's actually I'm pretty sure it's like 20 or 30. Oh, I mean more. It's 20 chapters of lessons that are collected into one giant video, and I think part of this is a result of that. So it's not like perfectly smooth going between each one. So anyways, I mean, humbug, as it were. Anyways, I I think we're gonna call it here for the day. Well, I'm so that was about an what was that? Was that an hour of the video? Because I felt like I was. It's not quite an hour. 48 minutes. So the first 48 minutes was just on these two. I feel like that. I don't. I felt like for the second half there was a lot of stuff that I was just not. I didn't have much to comment on it because I'm trying to comprehend it. And a lot of these functions that we created were really short, really simple, so it wasn't like with this one. I feel like this should probably have been more there probably should have been more of this kind of function where it's like there's some depth to it, some stuff to understand. But like just returning a lucky number, I mean this functionally this could have been done by creating an integer just called lucky number. Like I guess like theoretically we could go in and put like a random number generator or something inside this function, but we didn't do any of that. With say hello, I mean this is literally just printing hello there. Like we can it is more lines. It's like fewer characters if I want to call this, but it is the same number of lines to just print this. I think the most useful information for me personally that I've picked up on this one was finally understanding what the fucking argument was, which like for years confused me because I had heard the term and I just kind of sat there not really understanding it, but finally getting it explained where it's like, okay, we create a function and then that function has a parameter. And that parameter, when we call it when we put something or when we call the function later, we pass an argument in the same space that we put a parameter. So it's basically just a matter of if you're creating it, if you're initializing, it's not initializing. If you're creating a function in the first place, this is a then you call this a parameter. When you're calling the function, you pass an argument through it, which I don't know how it was explained to me before. I didn't. I all I remember is that I didn't understand it. So then here, right? Like when we come here, when we created this is our parameter, and then when we called this, H and I are our arguments. Okay. I think I understand this lesson pretty much. I still would like to understand some of the things we did in the one definition rule, but I also think that was probably mostly supposed to be a lecture portion. Like we could follow along, but the stuff that it's kind of like with the setup and getting the development environment prepared. It feels like it's more it's more just do the thing and then look at why that doesn't work. Like you don't have to understand why all of these things work. I just started this course myself. Good to see someone else also working on it. Ooh.
Welcome to the throne of God, mortal.
I need to I need to get my my notifications on this scene. But yeah, I appreciate the follow. I hope you enjoy your stay. Yeah, so far this course I think has been very very good. I've been offering some criticisms here for like the last 5 minutes. I've been complaining about how the very beginning of this chapter is handled, because I feel like it's kind of incongruent with the rest of the course so far. I mean, this part was fine. The one definition rule section, I think I had a bit of an issue with, but it is very good. I still recommend it. I still think it's good. Someone commented on one of my VODs that it was that this is not a good video, and I'm kind of curious as to why. Main pro with this is that it actually tells you how to set up Visual Studio Code properly. Yes. Setting it up takes fucking forever. It is so difficult to set up in the first place. But anyways, I think I'm gonna. You caught me kind of at the end of what I was planning to do today. We going into this function section, function declaration and function. Seeing you also have rooster.exe is so funny. I mean, it works. It makes sense. I figured not a whole lot of things that I'm typing that use RO, and I can just hit tab. But yeah, it caught me here kind of at the end. I think I'm gonna what's my where's my is this your first language? Yes, it is. I know. I mean, it's one of those things where I've never been a coder. I've never done any of that stuff. I had a high school course of JavaScript or whatever that was very that was a long time ago now. And then I had I messed a little bit with Unreal Engine 5, and that uses C++, but it's less about the C++ in that one. All right, so let me get my stuff here saved. Yeah, I did comp sci in high school 2 years ago. I haven't been to high school in so long. Oh god. All right, let's close this out. And where's my progress sheet? All right. what is this one called? Function declaration and definition. And we're at 15, pretty much 15 hours flat. Well, high school UK. I mean, I haven't been to high school anywhere in a long time. 15, yeah, so we're basically at the 15-hour mark. So I don't know what the difference in leaving age is. I mean, in the US, I think you typically graduate. High school is your 12th year of school. I think, because I think elementary school or primary school is usually first to fifth grade. First to fifth or first to sixth. I'm not 100% sure on it. I haven't been in high school in something like maybe more than 10 years. Wait, how old am I this year? I don't remember. Yeah. It's been a while. It's been a while. All right, so we got our timestamp figured out. I'm going to go ahead and go over here. So, I appreciate appreciate you guys coming to hang out with me today. It's been a hell of a journey, I think, with this. It's been a lot of stuff to learn. I mean, I'm gonna keep doing it, a little bit every day. So we'll be back tomorrow at the same time for this. I'm also gonna be live in like, is it 6 hours? Yeah, 6 hours from now. If where I'm gonna do some video gaming. Quickly before you head out, what are you learning coding for? So I think I mentioned before that I did a little bit of Unreal 5, and because I have uh, access to one of those courses, I think it would be cool to do that as well. So C++ is kind of the first. C++ is the language that Unreal 5 uses, and there's a simplified thing that called Blueprint that is also C++. So game dev stuff is kind of my main goal my eventual goal. I've talked about it for years, but like never do I never have I actually committed before I started streaming C++. So that's it's like okay, numbnuts, you're gonna actually walk towards your goal whether you want to or not. I use C++ for programming game engines and other graphics programming stuff. That sounds like what I'd like to eventually do. So we'll see if I ever get to that point. Hopefully, maybe, potentially. But yeah, anyways, I'm gonna stop rambling now. I'll be live again in like 6 hours. I'll be playing some Misadventures of Tron for the PS1. And we'll be back with some more C++ tomorrow around the same time that I am normally live, so 22 hours from then. So yeah, see you guys then later. Bye.